All right, so hello everybody. Greetings of the day. A little bit of things that I'm going to talk about are basically the buildings that we are currently living in or working in, or are probably going to go back to. So this is smart buildings. Now, the new normal that I'm referring to is obviously the pandemic-induced situations that we are currently facing. A little bit about me. I'm a projects and service engineer working with Honeywell, HBS, and I take care of the North Indian region. I currently have about 78 contracts that I'm handling for multiple customers. So a lot of data that you're going to see in this presentation is actually based on my personal experience and all of the projects that me and my team have implemented in the past around 2 years. So there's that. So to give everybody a little introduction on what is building automation. So it basically comprises of systems like the fire alarm system, the access control system, the CCTV, HVAC, and a little something called BMS. So BMS stands for Building Management Systems. All right. Now, why do we do it? Because the building owners want to ensure the life safety, security, and of their occupants. And in addition to that, they want to reduce the operational expenses. So yeah, energy management plays a vital role in building automation. Now, when does this happen? It actually happens around the clock. So BMS is something that goes on, throughout the day, 24/7, 365. There's absolutely no breaks there. So we look at what we're going to start off with is how the world used to work before the pandemic hit, right? So you can basically divide these the systems that we have installed in a building into three major groups. The first one is obviously life safety right here, which comprises of the fire alarm system and the fire suppression system. The FAS has addressable or conventional panels, which you must have seen in any and every building. They have detectors installed on the false ceiling, sometimes below the false floor and sometimes above the false ceiling, which is at the true ceiling. So they basically detect smoke and raise a fire alarm. The FAS is also used in case of emergencies, like an earthquake or a typhoon or something like that, or even a medical emergency, just to raise an alarm in general in the building that something's gone wrong. The FSS has multiple systems. Some of them are non-automated. Now, these include sprinkler systems and fire extinguishers that are strategically placed at certain areas in the building. Sprinklers, I say non-automated because their function is very localized. There's a little bulb on top of every sprinkler head, and it just breaks. So it's a very physical or a mechanical way of actuating that system. Another very specific FSS or fire suppression system is something called the FM200 system. Now, this comprises of a non-interactive gas, which can either be FM200 or NOVEC 1230. This is usually installed in data centers where protecting the data is very important. So the FM200 usually works by removing the heat from the fire triangle, and that's how it eliminates the fire in any area. Now, the next system that we look at is the security system, which comprises of the CCTV and the access control. Again, the CCTV, as everybody knows, there are digital or analog cameras that are installed in the field. They're connected to a controller that has a GUI and a local storage device that simply records videos. The access control is slightly more sophisticated. It uses readers in the field that take the input from a user of their card or their biometrics or their PIN. And that's how they give access to somebody inside a building. And finally, we have the HVAC control, which involves a lot of control loops and such things that control the temperatures, the AHUs, the VFDs, the dampers, and so on and so forth, to basically give the occupants of a building a very comfortable space to sit inside of. Now, what I want all of you to draw, or rather conclude from this old model, is the simple fact that all of these systems were majorly kept in a manual closed control loop, which means that there was human intervention required at every step of the way, for most part, okay? And the control and monitoring of data was all localized. So if I have a single site and it has these systems installed, all of the data coming from this site is going to be localized on that site itself. So if somebody wants to control or monitor various parameters of a smart building, they would have to either go to the site or be locally connected to the network of that site to get the data. Now, what happened next? We were hit by a pandemic. Everybody was forced to stay at home. A lot of things changed. However, these buildings were still standing and all of the equipments installed inside of them was still working. A major example of what did not change is the fact that the data centers were still running. All of the giants in the IT sector that you see, even though they sent their employees back home, their data centers were still running, and not just running, they were actually more critical to stay up, because if the data center went down, then everybody's gonna panic because nothing's gonna work. In addition to that, the telecom sector was running as well. So how did this $70+ billion industry pivot or respond to this highly changing situation in the world? Well, the very first thing that happened was the fact that all of the data that was previously localized was now moved to the cloud, so that building managers and people who have multiple building portfolios could look at everything, or rather could look at how their buildings were working or functioning in the palm of their hands remotely, right? That was the very first thing that happened. Remote access was given to almost all building managers, not users, but the managers. So that's there. Now, what happened next? Now, if we look at the fire alarm system, not a lot changed there, because the fire alarm system continued to work as it was. The only changes that were made was the fact that a network adapter or a Modbus card was introduced to the controller, so that the data from the field could be transmitted remotely to a central SCADA system, wherein people could also monitor and acknowledge alarms, if in case there were any that were coming from the field. Now, coming to the access control system, quite a lot of things changed. Now, biometric input to enter into a site was completely abandoned. So what came in instead of biometric access was facial recognition. And the next thing that was taken up was the contactless cards, or even optical proximity sensors, that are actually now being used to access secure areas and buildings. Another thing that was an add-on was what we call the occupancy sensors. So a lot of buildings, or rather common areas where people would gather, say a cafeteria, were installed with an occupancy sensor, and they would only permit maybe 5 or 10 people at a time, and they would display the same outside the seating area or at the doors. And as soon as that permissible limit was reached, the access to that area would be stopped until and unless the people inside came out and more people were allowed to go in. And that was one. Now, coming to the CCTV systems, what changed? A lot of thermal cameras were installed at at the entrance of every site, or a corporate office or a mall, so on and so forth, to basically automatically measure the temperature of the incoming crowd. And they had these little alarms or buzzers that would go off in case the temperature of the individual was above a set point, which would obviously indicate that the person is sick and they should not be allowed entry to closed space. Another thing that happened was not just the installation of new hardware, but on existing hardware. So existing cameras were fitted with, video analytics servers to allow them to also, monitor temperature and even for crowd control, and to ensure that people were maintaining the normal 6 feet distance, and so on. So that's how the CCTV system changed. Now, a majority of changes came in on the BMS and the HVAC side, where manual filters, air cleaners, and even UV filters were installed in the fresh air intake of AHUs. So AHU is an air handling unit that basically supplies the cooled air inside a building. So that was there. More filters were installed on the return air side of the ducts, so that there was further filtration of the air that was being circulated inside a building. This is, of course, to ensure that the air is as clean as possible, as germ-free as possible. And there were a lot of sensors that would pick up data on CO2, CO, PM2.5, PM10, and so on, were installed to, give a sort of healthy buildings kind of a reading. That this is the healthy building score of this particular building. This is the indoor air quality in real time. Now, this was visible to not just the building owners, but also to the users and the occupants, so that, as soon as return to work started, I mean, we're all coming back to work in a phased manner. So people need to be reassured of the fact that where they're going, the buildings that they're stepping inside of are safe to work in. So that's why we've had that. A lot of healthy building parameters were introduced. So coming back to what this conference is about, of course, the building automation industry didn't exactly go into the nanoscale, but we did get into the micro scale, wherein we are now monitoring, or rather focusing a lot more on monitoring the indoor air quality, ensuring that the air that we are supplying and circulating inside a closed space is clean, and the circulation is also constant. So I'll move on to showcasing a bit of data that I have from the projects that I have and my team have done in the past 2 years. So if you look at the landscape, we can basically divide the end users into builders. So builders are those that have a huge workspace, and then they either rent it out or lease it out to tenants, right? Then we have the corporates and the office spaces. Now, these are all of the companies that you can think of that have physical offices. Then we have the hotels, or the hospitality industry. Coming up, we have the malls. And finally, we have two very stringent places. Those are factories, manufacturing units, or rather, and the telecom sector. So the telecom sector has a lot of data centers and MSCs. So an MSC stands for a micro switching center. So there's that. Now, if we look at the builders and those who did not adopt to, or rather did not adopt any of the new changes that came in. So there's a total of 9 out of 11 who did not. So a lot of times builders are reluctant to adopt new technology because they simply say that the tenants will do it themselves, so they don't really have to do much about it. However, the two that did jump on this bandwagon, so this was basically a single customer who had 2 different sites, and they wanted to monitor parameters of those 2 sites on a single platform. So we did that for them. It was remote monitoring that we introduced, and they had, and now they're also planning to include their other sites across the country on the same, dashboard or the SCADA system. Next up were the corporate and office spaces. So as you can see, 15 out of 18 adopted the new technology. That's obviously because, they want people to come back to work, and they want their employees to know that they're doing something for their well-being, right? So a lot of thermal cameras have been installed. A lot of real-time AQI sensors and their displays have been installed. The access control technology has been completely changed, to ensure that things proceed as smoothly as possible. If we come to the hotel side of the businesses, I take care of 7 sites, and none of them decided to go with any of these automated solutions. This was majorly because hotels lost a lot of business during the pandemic because they were completely shut down. So what the hotels have done is they've decided to go on a rather physical or a manual way of doing things. They have physical hand sanitizers and they have the manpower. So they usually manually tell people to do certain things and to maintain a 6 feet distance and so on. A similar trend was observed with malls, wherein 3 out of 4 did not say yes to any of the new technology. The one that did, they implemented the new technology on the AHU and the HVAC side because they wanted to ensure clean air indoors. So that was there. Now, if we look at the factories in the telecom sector, now these guys are the ones that did not stop working even through the pandemic, because they basically form the backbone of not just India, but throughout the world. The manufacturing units, a lot of them were used to manufacture masks and oxygen cylinders and so on. So, and as we know already, that these guys adhere to very strict safety policies and HAC rules and guidelines. So there was complete adoption of new technologies. Whatever and everything that we proposed to them, they implemented immediately. Now this, I'm talking way back in 2020. So these implementations, the 23 sites from the telecom sector and the 5 sites on the manufacturing side, by the end, or rather the first quarter of 21, we had the latest technologies working there. So there's that. Looking at a summary, so 68% of the total contracts in North India, or the total sites in North India that's currently being taken care of by Honeywell, has adopted to one or more of the changes that I've talked about in my previous slides. So it's not bad. We're still pushing the 37 or rather 32% that has not yet, and we're quite positive that they will, because everybody wants to bring people back and kickstart their businesses. So there's that. Now, of course, anything new that is implemented so quickly will obviously have its own drawbacks. And these changes, the fact that we have implemented the remote monitoring of such sensitive systems and made the data of such sensitive systems available online, has its challenges, or rather comes with its own set of challenges. The first and foremost is cybersecurity, of course. Once you give the control of your building, right? The fact that someone is able to remotely monitor or control the AHU or the fire alarm system of a 30-40 floor site, it simply opens the site up to cyber attacks. And people with malicious intent, they could turn off the AHUs, they could set off fire alarms, and that would eventually lead to a lot of chaos. So yes, what we need to look at as an industry right now is stringent cybersecurity norms that need to be followed, not just by service providers, but also by the end user. Because a lot of times the breach that happens in a secure system is because the end user is not careful of how they're accessing their data. Another inherent issue that we have with, say, the fire alarm system is false alarms, right? So the reason why the old model or the world before 2020 in building automation used to have these manually controlled closed loops is because we have a lot of false alarms. So every time there's a false alarm in the field, we need human intervention to verify whether if there's an actual fire on an emergency or if it's just a false alarm, because we can't, have an entire working site, vacate the premises, just on the basis that there was dust in one of the smoke detectors. We can't have that. So having a completely automated system, of course, introduces this new challenge of how are we going to deal with these false alarms. And as a result, we of course need to have more and more checks and balances that need to be implemented. So once there is an input inside the control loop, we have to have a lot of verification that needs to happen before the output is triggered. Another reason that a lot of times is overlooked is the simple fact that the sensors themselves, the ground level devices tend to go bad after a certain period of time. And of course, we are looking at a system that works 24/7. And it's a given that it's going to go bad. The temperature sensor, after having worked maybe 2 years, 3 years, is going to drift. Its values will be inconsistent, right? So that needs to be checked on a regular basis. Old equipments should be overhauled and upgraded to the latest and the newest technologies. So there's that. Of course, there's a lot of things that need to be implemented, but at the same time, I'm quite hopeful that the world that we are now stepping into is a lot more safe, is a lot more secure, and a lot more smart than it was just 2 years ago. We have been able to implement technology so rapidly. I remember talking to my customers in 2019 and telling them, remote monitoring is the future. It's you need to get on board, get on this, jump on this bandwagon. And little did we know that it's not just of the future. I mean, it's going to come at us so fast, and it did. So there's that. Thank you so much for your time.